Hello, everyone, and welcome to this episode of Crowder Beaker Solves. Today we're still drawing Lewis structures, and this time we have a Lewis structure that is actually an ion or a polyatomic ion. There's a whole bunch of polyatomic ions out there, and they are ions because they've either mostly gained, or lost electrons along the way. But they are covalently bonded within themselves, and so Lewis structures are a good way to show them or represent their structure. So we're going to start with this one. They're pretty much the same as doing all the other Lewis structures with a couple of little added things to it, which we'll show you in a minute when you see it. All right, so Lewis structure for nitrite ion, NO2 with a 1 minus charge. So first things first, we have to add up the total number of valence electrons. So there's NO2 with a 1 minus charge. And we look at the periodic table and find that nitrogen is in column 5 of the tall columns. Oxygen is in column 6 for a total of 12. And then we have this -1 charge. So what do we do with that? Well, electrons are negative, and when a group of atoms picks up an extra electrons, it becomes more negative. So what you're going to do is add an electron to the total for each of the negative charges. So if this was -2, we'd add 2 electrons. In this case, we'll only add 1 for a total of 18 electrons. Okay. It's kind of like nitrogen and 2 oxygens got together to pool their electrons, and somehow they grabbed an extra electron from somewhere and added it to their pool, and so they have an extra one to work with, which is nice because it makes it a nice even number as well. So we're going to start with our nitrogen in the middle, oxygen around the outside. We'll give them all their 6 more dots to make 8, and that's 16 electrons. This is going to be very similar to the SeO2 that we did in a previous video. In this case, I've used up all 18 electrons, but the nitrogen is not satisfied yet. It does not have the octet. So I'm going to quickly draw the double bond. We're going to shift a pair in and make a double bond. And then because this is an ion, it has that extra electron. But it's not obvious when you look at the Lewis structure. You'd actually have to count the electrons to find out if it has an extra electron. And so what we chemists do is typically, because it's an ion, we're just going to put it in brackets and show its charge so that anybody quickly reading along can be like, oh, that's not just NO2, that's NO2 minus, and it has that charge there. Also, to be technically correct, I probably should draw the second one because this would also exhibit resonance. If you haven't learned about resonance yet, check out my previous video on SeO2 and SeO3. And so both forms are appropriate, and both forms probably exist millions of times each other every second as this thing undergoes resonance and shifts back and forth. So there you have it. That's one Lewis structure for nitrite ion. Remember to add or subtract from the total for any negative or positive charge you have. So let's do another one. This is yours to try. Similar one. Instead of nitrite now, this is nitrate. So we have the Lewis structure for nitrate ion NO3 with a 1 minus charge. So take a moment, pause the video, see if you can draw this one properly, and then we'll check the answer in just a second. Okay, if you were able to do that, congratulations, and check out my Lewis structure that I have here. Again, we have a negative charge, so I had to add 1 to the total for 24, and I get this situation where there's 3 oxygens, one of which gets a double bond. We also put the brackets around it with the charge, and that would be complete. Now, to be technically correct, I probably should draw the other 2. I wanted to make this one bigger, so I kept it just the 1. But I could just as easily put the double bond there or there, and they're all correct, and they're all resonance forms of each other. So there you have it, a couple of ions with resonance to draw, and I hope you enjoyed that. And if you have any suggestions of other Lewis structures you'd like me to draw, you can send them to me. In the meantime, happy drawing and have a great day.